Hello and welcome to our lesson today. In this lesson, we are going to see if Kenyan runners are faster than Ethiopian runners. And to do that, we are going to use a sample of our data. So we have some few data points here, which is just 10 samples. And we'll want to know if actually the Kenyan 10,000 meters female runners are faster than the Ethiopian 10,000 meters female runners. So the data set here is in seconds. So this is the second time that they've taken to run the 10,000 meters. So we are going to mathematically prove that. I know as we can say that Kenyans are faster or Ethiopians are faster, but we don't have the reason to say it so. So we want to prove that mathematically. And to do that, we need to do certain things. We need to use what we call a t-test to be able to establish if there is any difference in the means of the two groups of runners. So we're going to do what we call a t-test to do that. And to calculate the t-test or to do a t-test, we need to get some few things in place. So we need to get our T-statistic, what we call a T-statistic. And then we need also to get our confidence level. And we also need to get a critical value. And the degrees of freedom. So to start us off, we will start by looking at the formula for calculating the T-statistic. So for us to get our T-statistic, our formula is equals to X bar, which is the mean of the first group, minus X bar 2 divided by the square root of the variance of the two groups, S squared 1 over the total number of the population, total number of the sample, and 1 plus S2 divided by the total number of the population in that particular group. So now we go on and calculate the values for our formula, and we start by the mean. So the mean, as we said, is the summation of all the values, and you divide it by the total number of your values. So for the Ethiopian data points, we get the mean. If you add all the values, you get the mean of 1901.992, and for the Kenyan one, you get the value of 1839.737. And then after you calculate your mean, we need to get this lower part of our formula, which we are getting the variance divided by the number of data points. So the formula for calculating the variance is basically given as a summation of starting from 1 to n of the difference of each of the particular data points, which is xi, minus the mean of that particular group squared. So you're getting the squared difference, and then you divide by n minus 1. So this formula gives you the variance of that particular data points. And then if we use this formula to calculate the variance for the both the Kenyan and the Ethiopian values, then we will get the values as follows. So for the Ethiopian, we will get the value of 1977.73. And for the Kenyan group, we will get the value of 1146.44. So that gives us part of the lower value. And now, so this gives us the S1 and the S2 squared values. So this is the S1. S1 is the Kenyan, and then the S2 is the Ethiopian value. So once we get those values, now we divide by the total number of the total number of the data points. So we will get our formula. If we write our formulas with the values that we got already, we will get the formula looking like X bar, the first mean, which is the Kenyan mean, will be 1839.7 1.737, and then we minus the Ethiopian mean, which is 1901.992. Then we divide by the square root, so the square root of our first variance for the Kenyan values, which is 1146.44 divided by 10. And then we add that to the Ethiopian value, which is 977.73 divided by 10. So now, once you calculate all this, minus and then add these two parts of our formula and get the square root, then you will get a value of negative 3.522. And this is the value for our T-statistic. Okay, now that we've gotten our T-statistic value, which is negative 3.522, we need to remember what we're trying to do. We're trying to find out if the Kenyan runners are faster than the Ethiopian runners. So that means our hypothesis here, when we set our null hypothesis, we are saying that Kenyan runners are not actually faster than the Ethiopian runners. So that means the mean of the Kenyan runners, let's just say x1 for the Kenyan runners mean is greater or equals to the one for the Ethiopian runners, which we are demarcating here as the mean for the second group. So that is our null hypothesis. For the alternate hypothesis, for this particular case, we're saying that actually the Kenyan runners are faster, which means that the mean of their speed in terms of seconds is less than that of the Ethiopian runners, which is the second mean. So that is our hypothesis. That's what we want to find out, to prove. So now we need to set our confidence level, which you should have decided before you start to test your hypothesis. So confidence level, basically, you set it prior to starting to do your calculation. So for this case, we set our confidence levels to 0.05. So basically, we are saying that we need to have 95% confidence to reject the null hypothesis. And so once we set our confidence level, we need to get the degrees of freedom. Now, the degrees of freedom calculations depends on your data. So if there is uniform variance between the two groups, you have a different formulas, which you can look it up at the notes. And then if you have an equal variance, then you have a different formula for that. So for here, we already gotten our degree of freedom to be a value of 16.809. So that is our degrees of freedom for this data set, which has an equal variance. So we have 16.89. So for now, if we want to prove that actually the Kenyan runners are faster than the Ethiopian runners, we need to prove that their mean is less than the Ethiopian runners' mean. And that is where our t-test comes in. So we want to look at our critical value, which will determine when we reject the null hypothesis. So for the critical value, we look this up on the t-table using our confidence level and the degrees of freedom. So in the t-table, you look up where your confidence level of 0.05 is, and then you look at the side where the 16.89 is or falls between. So when you look that up, you will get a value of 1.740 being your critical value. So if our T-statistic is less than the critical value, that's when we reject the null hypothesis. So if our T-statistic value is less than our critical value, then we reject the null hypothesis. The null hypothesis. So in this case, we have gotten our T-statistics to be negative 3.522, which if you compare it with our critical value of 1.740, then you could say that this value is less than 1.740. So that basically means we reject our null hypothesis that says that the Kenyan runner's mean is greater than or equals to the Ethiopian runner's mean, and we take our alternate hypothesis, which says that the Kenyan runner's mean is less than the Ethiopian runner's mean, which basically concludes that the Kenyan runners are actually faster. According to this data set, Kenyan runners are actually faster than the Ethiopian runners.